Hello guys, I want to look at a very interesting topic, which oftentimes people get it all mixed up. We are talking about a magnetic particle testing NT, and we are looking at the differences between relevant, non-relevant, and false indications. Especially this non-relevant and false indication could be very problematic for some personnel to differentiate. I personally had that issue while I was doing my ASTM E1444 training. So I hope this short video will help in clearing out differences. This one is pretty straightforward. Everybody knows this. Relevant indication are also what we call the true indication. These are indications that we eventually classify as defects. So these are indications that you know you are going to reject when they fail to meet the acceptance criteria. So this one is pretty straightforward. If I see a crack, if I see a long undercut, if I see porosity that is above my acceptance level, this is pretty straightforward. We reject it. We don't accept relevant indication. We call for repair, we reject the particular item that we're inspecting. That is pretty straightforward. Non-relevant. If you look at the common term between these two, you are seeing the word relevant. So, what is the similarity between these two relevant, the real relevant and the non-relevant? They are both caused by the action of magnetism. So, relevant indication is caused by magnetism, non-relevant is caused by magnetism. But false indication is not caused by magnetism. That is the major difference. False indication is not caused by magnetism. So any indication that is caused by magnetism, but it is not relevant. Now, this could be due to one, the geometry of the material. This could be due to excessive magnetization. This could be due to the edges of the material. We have things like a keyway. We have things like keyway, you have sharp edges, you have points. Then you have things like what we call the similar metals. So what do these things do? They will form points because in your relevant indication, I may have a crack, and because there is a crack, when I put the magnetic particle and I put a magnet, the crack will now make the particles to be attracted towards it. So you have particles settled around this crack. So it is the magnetism that is causing these particles to settle in the crack. So because it's not what we really want, because it's an indication that is caused by a true defect, it becomes relevant. The same thing that this crack does, every other thing you see here will do it. But because they are not caused by true defect, they are now referred to as non-relevant indication. So if I have a poor geometry, the geometry, let's say I have wells like this. If I have indication settling down in spaces between these two wells, because of the magnetic effect, particles may cluster around this area. This is not a defect indication, but it is caused by the geometry of this material we are checking. So that becomes a non-relevant indication. But it is the magnetism that is attracting these particles to this point, thereby causing this indication you see. But it is non-relevant. Now, I can also have the legs of my magnets. Because of the excess magnetism, particles can trap around this area. It is the action of the magnetism that is causing the particles to be trapped around this area. So, due to excess magnetism, or even sometimes excess particle trapping around this excess magnetism, it can lead to non-relevant indication. Then sharp edges. If I have edges Especially if I have a T-joint where I have the edge around these two. Indications can also clap around here because of the magnetic action and all that. Keyway, then the similar metals also. So if I have two metals that are magnetic, that are joined together, particles can be trapped around this area where they are connected. You will think it's a defect. So, how do you differentiate between true indication and which is the relevant indication and the non-relevant indication? Because the third one is pretty straightforward. For relevant and non-relevant, when you see an indication like this and you are not sure, you do it again. Do the empty test again. Clean that area properly. If it is field work you are doing and you see false indication, get your wire brush, get your power brush or whatever form of cleaning, do more cleaning on that point. You will discover that if it is caused by excessive magnetism or edges, the more you do it, the more it becomes clearer that it is not a true indication. In some cases, it will not even repeat the second time. Or you try the third time, it may not repeat again. And it will not be giving you, it will be giving you a clear, defined shape. So, for example, if I have a crack is not a uniform geometry. So, you will always see that rough particles. But if I have a non-relevant indication and you are seeing it very smooth, very straight, very sharp, you will know that this is caused by the action of either of these with the magnetism. So do it multiple times, you will just differentiate whether it's relevant or non-relevant. False indication, on the other hand, are caused by external factors, not as a result of the magnetism. It could be dirt on the material, improper cleaning. It could be contaminated particle. It could be maybe while you are doing the magnetism, you got foreign materials into the material. Those ones are false indication. They are not caused by the action of magnetism. Also, the geometry can also lead to false indication, but in this case, you have particles settling down around the geometry, but it is not as a result of magnetic action. If questions come in the exam where you are so confused about false indication and not relevant, just look at the ones that can be affected by magnetism. So if I'm asking which of this is a false indication and I see dirt there, obviously you know that the dirt is an external material. It is not caused by, it will not, the effect of the dirt is not affected by the magnetism. You just know that is false indication. But every other factor that can be affected by magnetism becomes a non-relevant indication. Good. So now, if we practically illustrate this, as you can see particles that are settling down on this weld. You can see particles. Somebody might want to confuse that this is a defect. Like these particles that are gathered there, you want to think that this is a false indication. They are all settled down because of the geometry of the material and magnetism. Another thing I didn't talk about, gravity. Gravity is not caused by magnetism. Gravity is caused by the shape of the material. So gravity falls under false indication. Gravity falls under false indication, not under non-relevant. But if you look at this place, you can see a very small crack, a long crack on the toe here. You can see a crack on the toe here, which oftentimes you may want to confuse with this one on the interrun of these two words. So if I'm not sure what I will do, this one that's okay, maybe I'm thinking maybe it's because of geometry or something. If I clean this enough and do it multiple times, I should be able to see this crack coming. This is a toe crack. If you look at this second one, this one is a little bit more obvious. This one is an heat affected zone. It's a heat affected zone crack. You can see the crack is on the heat affected zone. The difference between the heat affected zone crack and the toe crack, in the toe crack is directly on the toe of the word, but this one is outside of the toe of the word. You can see this. This is a true indication. But if you look at this one in between this space, this is a non-relevant indication. Then if by either by gravity or by an external depth, contamination. Maybe I didn't clean the coating very well. It becomes a false indication. But just to confirm, I can clean this again, do the process multiple times. If it is a true indication, you will see that it will keep repeating and you can see how the shape is coming out for this end. If it affected zone crack. I hope we've learned something from this video. Thank you for watching.